Hello, my name is Dr. Lena Mathews, and I'm an assistant professor of medicine at Johns Hopkins. At this year's American Heart Association's scientific sessions in Philadelphia, I'll be presenting our research findings on protein markers associated with hypertension and hypertension-related complications in a session called Novel Biomarkers for Cardiovascular Health and Disease. Hypertension is a leading risk factor for cardiovascular disease worldwide, and the number of people with hypertension continues to grow. There's also data that blood pressure control worldwide is worsening. Poorly controlled hypertension leads to end organ damage such as heart attacks, strokes, and heart failure. Therefore, understanding the underlying mechanisms of hypertension may help to prevent the development of hypertension and hypertension-related complications. While genetics may explain 30% of variations in blood pressure among the population, the rest is related to the environment. Therefore, studying proteins in the blood, which are a result of the effects of both genes and the environment, could potentially help us understand the underlying mechanisms of hypertension. In this particular study, we examined the association of nearly 5,000 proteins in the blood with the development of hypertension among 5,000 participants free of hypertension in the atherosclerosis risk and community study. We then validated any significant proteins we found at a second time point in another group of ARIC participants without hypertension. We found that higher levels of one protein, metrolysine, also known as matrix metalloproteinase 7, was significantly associated with the development of new cases of hypertension. We then examined the association of metrolysine with the development of complications of hypertension, specifically heart attacks, stroke, and heart failure, and again found a robust association between higher levels of metrolysine and these hypertension-related complications. Metrolysine is an enzyme that degrades the extracellular matrix, which is the supporting structure of organs such as blood vessels. Metrolysine is potentially involved in the process of changes to the vasculature that lead to the development of hypertension and sustaining hypertension, and thus resulting in end organ damage. Future research on the mechanisms of metrolysine in hypertension could potentially yield drug targets for the prevention and treatment of hypertension. Thank you very much for your attention.